Welcome back to Science to Sleep By. Tonight, we are drifting into one of the quiet mysteries of space. Why is our solar system tilted? As Earth slowly turns beneath the stars, we'll explore how our planetary family moves through the galaxy, why its orientation is unusual, and what scientists believe may have caused this cosmic lean. Settle in, relax, and let the universe unfold around you. The solar system is not perfectly aligned with Milky Way galaxy. If you could step far outside our cosmic neighborhood and look back, you would notice that the planets orbit the sun on a relatively flat plane called ecliptic. Yet this planetary plane is tilted by roughly 60 degrees compared with the overall plane of the Milky Way. Scientists have known this for centuries, but the question remains fascinating. Why should the solar system be angled so differently from the galaxy that contains it? The answer begins more than 4.5 billion years ago, when a giant cloud of gas and dust slowly collapsed under gravity. As the cloud spun, it flattened into a disk, and from that disk, the sun and planets emerged. The direction of that original spin determined the orientation of our solar system, creating a local alignment that had little reason to match the broader structure of the Milky Way. According to modern astronomical research, the solar system's tilt is likely the result of chance conditions present during its birth. The cloud that formed our sun may have been influenced by nearby stellar explosions, magnetic fields, and turbulence within a giant molecular cloud. These forces could have given the young solar nebula a spin direction different from galactic plane. Scientists studying star forming regions today observe that planetary systems often form with a wide range of orientations. This suggests that there is no universal role requiring solar systems to align neatly with their galaxies. Instead, each stellar family develops its own unique angle, shaped by local conditions in the chaotic environment where stars are born. The mystery becomes even more interesting when we examine smaller tilts within the solar system itself. Most planets orbit in neatly the same plane, but not perfectly. Uranus, for example, rotates almost on its side, likely because of a massive collision early in its history. Even the Sun is tilted slightly compared with the planetary orbits. Some researchers have explored whether unseen influences, such as distant objects in the outer solar system, may have contributed to these subtle misalignments. While no single explanation has solved every detail, scientists generally agree that gravity collisions and the complex dynamics of planetary formation played major roles. The solar system's tilt is therefore not evidence that it is tilted against something specific, but rather a record of the events that shaped it billions of years ago. One of the most fascinating discoveries of modern astronomy is that tilted systems appear to be common throughout the universe. For many years, scientists assumed that planetary systems would generally align with the rotation of their parent stars and perhaps even with the broader structure of their galaxies. However, observations from powerful telescopes have revealed a far more complex picture. Astronomers have found exoplanets, worlds orbit distant stars that travel along paths dramatically tilted compared with the equators of their host stars. Some planets even orbit in the opposite direction of their star's rotation, a phenomena known as retrograde orbit. These discoveries suggests that the process of planetary formation is far more dynamic and chaotic than once believed. During the early stage of stars' life, neighboring stars can pass nearby, gravitationally disturbing young planetary systems. Massive planets may migrate inward or outward, pulling smaller worlds along with them and altering orbital alignments. Collisions between planetary bodies can dramatically change the orientation of entire systems. When scientists compare these distant examples of our own solar system, they often conclude that our planetary neighborhood is actually relatively orderly. Despite its tilt relative to the Milky Way, the planets generally orbit in the same direction and within a narrow plane. This remarkable consistency hints that while the solar system experienced its share of cosmic turbulence, it avoided some of the more extreme disruptions seen elsewhere in the galaxy. As Earth quietly circles the Sun tonight, we are part of a system that appears stable and predictable. Yet, those earliest history we likely filled with movement, collisions, and gravitational encounters, the solar system still serves as a reminder that even seemingly permanent structures are shaped by ancient events long forgotten. Every orbit, every rotation, and every angle reflects a story written during the birth of the sun. In this sense, the tilt is not merely a geometric feature, it is a fossil of the past, preserving clues about conditions that existed billions of years before Earth formed oceans, before life emerged, and before any observer could look up and wonder why the planets move as they do. Another perspective on the solar system's tilt emerges when we consider our place within the Milky Way itself. The galaxy is not a rigid structure but a vast, evolving system containing hundreds of billions of stars, enormous clouds of gas, dark matter, and complex gravitational forces. As the solar system travels around the galactic center, completing one orbit approximately every 225 to 250 million years. It passes through different regions of galaxy. Some scientists have suggested that these long journeys may subtly influence the solar system over immense periods of time. Gravitational interaction with passing stars, giant molecular clouds, and even the overall galactic environment could slightly modify the orientation of distant objects at the edge of our solar system. Although these effects are generally weak, the universe has an abundance of time. Small influences acting over billions of years can produce measurable changes. Researchers studying the outer reaches of the solar system continue to investigate whether distant icy bodies preserve evidence of such interactions. Meanwhile, sophisticated computer simulations attempt to reconstruct the conditions that existed when Sun first formed. These models often reveal that the birth environment of a star can be crowded and turbulent, with neighboring stars influencing one another before eventually drifting apart. If our sun was born in such a stellar nursery, its current tilt may represent the combined outcome of many subtle forces rather than a single dramatic event. What makes the idea particularly soothing is the realization that the solar system is not isolated. It exists as a part of much larger cosmic community connected through the gravity to the galaxy around it. The tilt we observe today may therefore reflect both local events from the solar system's birth and the broader story of its journey through the Milky Way. As scientists continue gathering data from observatories on Earth and spacecraft exploring the outer planets, new insights may emerge. Yet, even if every detail is never fully known, the mystery itself carries a certain beauty. It reminds us that the universe still holds questions waiting to be answered, and that every angle, orbit, and motion in the sky has a history stretching back through the unimaginable depth of time. Perhaps the deepest way to think about the solar system's tilt is not to ask what it is tilted against, but to ask what the tilt reveals about the nature of the universe itself. Human beings naturally search for the order and alignment. We often expect large systems to follow simple patterns, yet astronomy repeatedly shows us that nature is more creative than our expectations. The solar system's orientation reminds us that cosmos is shaped by both laws and chance. Gravity follows precise mathematical rules, but the specific outcomes of those rules depends on countless circumstances. A cloud of gas drifting through the space may be compressed by the shock wave of nearby supernova. Magnetic field may twist material in one direction or another. Neighboring stars may briefly pass close enough to influence a forming planetary disk. Tiny differences at the beginning can echo through billions of years, eventually determining the orientation of planets, moons, and entire solar systems. Scientists often compare the early stages of star formation to a vast cosmic weather system full of turbulence, motion, and unpredictability. In such an environment, no two stellar families are likely to form in exactly the same way. This understanding has transformed modern astronomy. Rather than viewing our solar system as universal template, researchers increasingly see it as one example among countless possibilities. Some planetary systems may be nearly aligned with their galaxies, while others may be dramatically tilted. Some may contain giant planets close to their stars, while others may have worlds orbiting at enormous distances. The diversity observed across the universe suggests that there is no single correct arrangement. Instead, each system carries the imprint of its unique history. For those studying the solar system, this perspective turns the tilt into something more meaningful than a simple angle. It becomes a clue to ancient events that can never be directly observed. Every degree of inclination contains information about processes that occurred billions of years ago, when the sun was young and the planets were still forming from whirling rings of dust and gas. Even today, scientists continue to refine their understanding through advanced computer simulations, observations of distant planetary systems, and measurements collected by space missions. Yet, despite remarkable technological progress, some mysteries remain unresolved. That uncertainty is not a weakness of science, but one of its strengths. Science advances by asking questions, testing ideas, and gradually improving our understanding of reality. The solar system's tilt is a perfect example of this ongoing journey. It encourages astronomers to look deeper into the mechanisms of star formation and the force that shape planetary systems across the galaxy. And as we reflect on this from our small world orbiting an ordinary star, there is something quietly humbling about the realization. Earth, the moon, the planets, and the sun are all moving together through the Milky Way at an angle established long before humanity existed. We are passengers on a cosmic wake while Those origins stretch back more than 4.5 billion years. The tilt of our solar system is not a sign of opposition or conflict with the galaxy around it. Rather, it is evidence of a rich and complex history, a reminder that the universe is shaped by both structure and surprise. As the night deepens and the stars continue their silent motion overhead, the solar system carries its ancient orientation through space, preserving a memory of its birth, and in that quiet tilt, scientists find not a problem to be solved once and for all, but a story that continues to inspire curiosity, wonder, and explanation across generations. As we conclude tonight's journey, we find that the solar system is tilted against nothing in particular. Its angle is simply a consequence of its origin, a frozen memory of the cloud from which it formed. In vast Milky Way, countless stars and planets likely possesses their own unique orientations, each telling a different story about their beginnings. And as you rest beneath Earth's night sky, remember that our entire planetary family travels through the galaxy at its own quiet angle, carrying the history of its birth across the stars. Thank you for listening to Science to Sleep By. As the universe continues its silent journey, make your thoughts drift gently among the stars. Good night and sleep well.